My name is Dan Lieb, and I'm the current president of the New Jersey Historical Divers Association, and we run the New Jersey Shipwreck Museum here at InfoAge in Wall, New Jersey. I'm in the museum now, and I'm in front of the Dunlap heat exchanger. The heat exchanger is an analog for the Titan submersible, and I'll explain why. The first thing I'm going to do is describe what the heat exchanger is and how it functions, and then I'll draw an analogy between the Titan submarine and this device. This device is called a heat exchanger, and what it does is it exchanges heat from one medium, in this case steam, for another medium, in this case water. And the way this works is it's set up as a copper tube with bronze rings fastened to the ends of this tube by rivets. Connected to those rings are bell housing on each side. One has no fittings that go through it, except for the fasteners. The other one has two large through-hole fittings. There are, inside of this tube, 610 copper tubes. Raw water, ocean water, enters through one of these tubes, this opening here. The water travels through 305 small tubes, turns in this bell housing, and then progresses out through 305 more tubes where it exits and goes overboard. What would happen is steam from the system, whatever the system is, turbine, piston, maybe it's running a pump on board the vessel, steam spent from the system enters this hole here, this aperture, and is diffused amongst all 610 copper tubes, which are filled with water. Water is nearly incompressible. But there's airspace, gas space around those tubes. When the steam is surrounding all of those tubes resemble a cold drink on a hot day. It sweats. The tubes sweat water. That water sweats off these tubes at such a rate that in full operation, what's going on in here resembles a downpour. That water is collected, it's condensed steam, it's collected and comes out a port at the bottom, travels back into the boiler, is reheated and used again and again. This eliminates mineral buildups in the system that could have disastrous results, like a boiler explosion or an engine jam. Again, it's a copper tube with bronze rings fastened at each end of the tube and bell housings at each end of the copper tube with its brass rings. This is basically the setup of the Titan submarine, which had dissimilar materials that it was constructed of. Carbon fiber body with titanium rings adhered to the ends, and then titanium bell housings at each end, one with a porthole, one with through-hole fittings that went to the electronics that were outside the system, and the entire system sat on its own frame. When this vessel sank, when the Cecilia M. Dunlap sank, this system was in operation, and when the hot device came in contact with cold ocean water, the device had a pressure differential on the inside. The inside chilled and the pressure dropped. As the vessel sank down 2 atmospheres, down to 66 feet, about 66 feet, the pressure on the outside increased. Finally, demolition charges were set around the wreck to clear it as a menace to navigation issuing the coup de grace, causing the entire system to collapse. Not the heavy-duty bronze rings and bell housings, but the softer copper. This is basically an analogy for what happened with the Titan submarine. The pressure was so great, the softer, more weaker material collapsed, while the outside material, the rings, the titanium bell housing, and the framework stayed intact. If you like what you've listened to, please hit the subscribe button and see other videos that NJHDA has to offer. And if you'd like, you can also visit our website at njhda.org. Thank you.